Hello and welcome back to Mr. Powers Teaches Algebra. I want to go over with you today augmented matrices. All right. An augmented matrix is something we can use as a mechanism for solving systems of equations, and it's especially useful for equations. Hold on. It's especially useful for when we have three equations, three unknowns, four equations, four unknowns. When they get really complicated, then an augmented matrix is a nice mechanism that we can use, nice little tool for solving these systems. And then if we know how to use some graphing calculators or other calculators like Mathematica or MATLAB, those are two big ones, but these will work in GeoGebra and Desmos as well. We can just row reduce them. Row reduced echelon form, I believe is what we call it. Then we have our solutions right away. So let me try to show you the method here and the operations we use. Okay, hold on. So the first thing we do is rewrite our system in a matrix form. And so we'll do it, we'll kind of do it like this. And what we're going to do is copy the coefficients. And we want it set up exactly like this, where we have the variables on the left side, in this case, x, y's, and z's. And then on the right side are our constants, our numbers, right? Whatever. Okay, so it's set up the way I need it, and it has to be set up this way. One column's the x's, the next columns are y's, the next columns are z's, and then on the other side, we have the equals numbers. We have to set it up like this, and then we give a lot of freedom when we mess with the matrices. Then we can manipulate our matrices, and it's exactly like manipulating our equations. Okay, and hopefully we can show that a little bit, because this is the example we did the other day in my last video with solving linear systems in three variables. We were manipulating the equations in order to eventually get down to, we went from three equations, three unknowns, two equations, two unknowns, down to one equation, one unknown, and so we can start solving and then back substituting. We can do that with augmented matrices, but we can even go further. We just manipulate them over and over again until we get like 1x plus 0y plus 0z equals something. Well, then we got x. We know what x equals. And then likewise, 0x plus 1y plus 0z equals something. Well, now I know what y is. So hope you'll see this. And that's what we're doing. So 1x minus 2y plus 3z equals, I'm going to put a little line here, equals 7. And then we got 2x plus 1y plus 1z equals 4. And then negative 3x plus 2y minus 2z equals negative 10. And I have made my augmented matrix. Now I want to mess with it. I want to play around with it, change things up. This one's actually seems really nice. I have to say, I really like the way this one's set up. And so I don't know if I'm solving this, I might want to use different steps than I used to solve this one. Because here's what we want to do is we want to get to the point where eventually we're getting to this. This is always the goal. 1, 0, 0, 0, 1, 0, 0, 0, 1. And then we got our, let's say, A, B, and C. Then I got x equals A, y equals B, z equals C. That's what I want to do. Okay, eventually. So right now, we got a 1 here and a 1 here. That's really nice. And then the trick is we need to get a 1 right here. And then I can start playing around with all this, I think. That's one way we can do it. I haven't done matrices in a while, but I'll just show you. So one thing we can do is always subtract one equation from another. And we did that the other day. So I think what I want to do is, or add two equations of one to another, stuff like that. So what I want to do is I want to get a 1 here. So what I'm going to do is I'm going to go, let's say, I could just add the row 1 to row 3. So actually, I think I'll write R3. So let's slide around here, actually. And I'm going to write here, I'm going to say R3 plus R1. That's going to be my new R3. So if we were doing this on our own, we could add these two up, right? And I can get a new equation. If I added these two, what would we get? We get x plus 3x is negative 2x. Negative 2y plus 2y is 0y. 3z plus negative 2z is positive 1z equals, and then 7 plus negative 10 is negative 3. So if I added these first two up, I'd get a new equation, and then I could keep using that equation, right? To hopefully get somewhere down the road. Well, rather than do that, add them up and then write a whole another equation, I'm just going to keep 3 equations. I'm just going to replace. I'm going to do this. I'm going to replace one of the equations I had and keep that in my matrix. So what we're going to get is this guy over here. My new matrix is going to be, well, I'm adding 1 and 3 together. I got to write here what I'm going to end up with. So I get, I'm not messing with anything but the third row. So I can write 1, negative 2, 3, 7. So nothing's changing except that bottom row. So 2, 1, 1, 4. And then negative 3, 2, negative, oh wait, no, I'm changing that one. So now I have negative 2, 0, 1, negative 3. So what I'm really doing is I'm replacing this bottom equation with this one. That's what I'm doing. And it is true. I made a new equation with things I knew, just like we normally would while solving these, because, right, we did stuff like that. We also did stuff where we just multiplied one row by 2 to get a new one right here, 4x plus 2y plus 2z equals 8. And that's something we could do also. I could have just said, you know what, I'm going to replace that middle row with twice what it was before and rewrite it that way. That's an operation we can do. Okay? Oops. Crap. Let's see here. Man, let's see here. Where did it go? Okay. So now, now that I got this, what I want to do, and what I'm trying to do too, is just show you, like, I'm messing with these matrices. It's just the same as messing with these equations. Whatever we do to equations, we can do to rows in the matrices, because you just imagine I'm just manipulating an equation. So anything I could do to equation, I can do to a row in a matrix. I can multiply top row by 2 and then add it to the bottom and replace it. I can do anything like that. We can add 2 rows together. So we can add them, we can multiply and add, and that's pretty much it. Subtract, whatever. So now what I want to do is I keep doing this. I'll do one more operation. We'll go over here, and I think what I'll do is I'll try to. What I really want is to get these to be zeros. I got a 1 here, so it's easy to get these zeros. I could just say multiply top one by negative 2, and add to the middle, and this will be a 0. So negative 2 times 1 is negative 2. So that, and I add that, it'll be 0 here. Oh, so the top one is not going to change. 1, negative 2, 3. And let's see, what am I doing? I'm doing the middle one. So I'm doing row 2 plus, or well, I guess plus negative 2, row 1. That's what I'm doing. So I'm taking that middle row. I'm going to add negative 2 of the top row to it. So negative 2 times negative 2 is 4, plus 1 is 5. Oh, I don't want to do that. I want to keep that a 1. Oh, that's okay. No worries. And then negative 2 times 3 is negative 6. Negative 6 plus 1 is negative 5. That's easy. Okay, and then we got negative 2, 0, 1. Oh, wait. I got to get this one here. I got to get the other side of our augmented matrix. We had a 7 here. Negative 2 times 7 is negative 14 plus 4 is negative 10. And we still have that negative 3. Okay, so I messed with it some more. Meh. Now if I multiply everything here by 1/5, that middle row, that's going to look really nice. So what do we do there? So let's do that. Let's go R2 is going to go to the same thing as 1/5 times R2. All right, so what do I get there? So we're just going to rewrite this whole thing, but I'm going to take 1/5 of R2. So I get 1, negative 2, 3, 7. To copy the first row, the middle row. All right, now is going to be 0, 1, negative 1. And that's going to be 1/5 times 10 is 2. So negative 2. And then I haven't messed with my bottom row, so negative 2, 0, 1. And that's negative 3. Okay. And that's just like taking 0x plus 5y minus 5z equals negative 10. It's the same thing as saying 0x plus y minus z equals negative 2. It's the same thing. That's all. So I'm just rewriting it. All right. So now what? Now what? Because I want to get, like I said, remember, we're trying to get to this. So I know what my variables are. So we keep messing with this. Let's go ahead and get this guy 0. Keep going. So I'll go, let's go here. Whee. And this time we're going to go, we'll add to row 3 2 times row 1. So R3 plus 2 times R1. All right. Let's see what happens there. So I get 1, negative 2, 3. Again, that stuff, we're not changing the top row. I'm only changing the third row here. I'm doing it real slow. You can do 2 steps at once. Sometimes, lots of times. But just to be safe right now, we'll do one at a time. I'm not messing with my middle row. But that bottom row, that one I'm changing. I'm going to add 2 times the top row to the bottom row. So 2 times 1 is 2, plus negative 2 is 0. 2 times negative 2 plus 0 is negative 4. And then 2 times 3 is 6, plus 1 is 7. 2 times 7 is 14, plus negative 3 is 11. All right. Very good. Very good. We're getting there. Now what? What else could we do? What else could we do? Ooh, this looks really nice. Oh, wait, no, that's not going to work. Now I say, let's get this. Then we could get this to be 0. That's going to be really easy. If we take row 2, multiply it by 4, and add it to row 3. So it looks like I'm just going to finish this. We're going to do this, and then I'll show you. We'll check our work with technology here. So now what I'm going to do, so I'm going to take row 3. I'm still messing with my row 3, and I'm going to add 4 times row 2, I mean. Okay, so what do we get now? So I'm messing with row 3, so row 1 and 2 are going to stay the same. So you can see these are tedious. But it's nice to be able to see this. And I will admit I've not done this a lot recently, so there might be a quicker way to do this. Just play around with them and you'll get it pretty quick. So 4 times 1 is 4 plus negative 4 is 0. 4 times 0 plus 0 is 0. So I got 0 here now. And then 4 times negative 1 is negative 4 plus 7 is 3. 4 times negative 2 is negative 8 plus 11 is 3. And we already know the answer to this. We know it's 2, negative 1, 1, right? Because we did it right here. We should get x is 2, y as negative 1, z is 1. And we are, you can see now, right here, 3z equals 3, z equals 1. So we are getting the same answer. It is working. Is it faster? Maybe, maybe not. But can you imagine, though, you got 4 equations, 4 unknowns? This might be a little bit easier to handle, and it's definitely more organized, easier to follow than this, where I was kind of jumping around a lot. I'm like, okay, I'll mess with these 2 equations, I'm going to mess with these 2. So just an alternate way to handle these. So now what? 1/3. I want to do 1/3 times row 3 to get this 1, 1. So I'm just going to say, you know what, row 3 is going to be 1/3 row 3. So that way I got my 1s in there. So 1, okay, so we're just kind of copy the matrix again, but finish that bottom row. Okay, and then we got 0, 0, 1, 1. Great. Now what? Now we want to get 0, 0 here and a 0 here. That's going to be a piece of cake. Not a problem at all. We're almost done. The hard part's done. Once you get it like this, you get 1, 1, 1 with zeros below it. It's really easy to start getting this out. Or you could even start back substituting. You know now z is 1, so you could just write this equation. If you really wanted to, you could write, hey, I got y minus z equals negative 2, but z is 1, so I got y minus 1 equals negative 2, so y is negative 1. You can see that already, and then you can plug it in this top equation. So you can do that too, but I really want to get row reduced echelon form. So let's just finish up what we're doing, and we will get the same answer. Okay? Hopefully this is making sense. Let me see here. So I want to get 0, 0 here, because I'm trying to remember. I want to get like this. So 0 and a 0 here. So let's add row 2 to row 1. So row 1 plus 2 times row 2. You can also switch rows around. I didn't mention that before, but obviously putting row 1 having row 1 at the top, if you wanted it on the bottom instead and you want to switch those, you could totally do that. That's fine, right? The order there doesn't matter. I didn't do any of that. So now what? Okay. Yes. Row 1. We're messing with row 1. Well, 2 times 0 plus 1 is 1. 2 times 1 is 2 plus negative 2 is 0. 2 times negative 1 is negative 2 plus 3 is 1. 2 times negative 2 is negative 4 plus 7 is 3. Okay. Keep going here. That's what I got now. Okay, and then I didn't mess with the rest. All right. Almost there. Now we're going to clear out both of these using this 1 because I got 0, 0, 1. Super easy to clear out these 1s here. And I will do 2 steps at once here for the sake of time. Let's get her done. R2, or R1, we're going to subtract R3 from R1. So we're going to do R1 minus R3. And we're going to do R2 plus R3. There. We're going to do those two at the same time because these we can do at the same time. If it's not obvious, then when you do them one at a time. But here, this is going to be allowed. So R1 minus R3. Oh, wait. Yeah, R1 minus R3. Okay, so that's going to be 1, 0, 0. 3 minus 1 is 2. All right. And then R2 plus R3. So I'm going to have 0, 1, 0. Negative 2 plus 1, negative 1. And then I didn't mess with the third one. 0, 0, 1, 1. Oh my goodness, I finally got it. There's my x, y, z, 2, negative 1, 1. And if you look at our last problem, our last video, that is what we got as well. Which one do you like more? Again, I might have taken a long route here to get this answer, but it does work. And it's nice to see. So if you want to see really quickly an augmented matrix in, let's say, GeoGebra, there it is. So easy enough. The way you do this is you type in. So I did, if you want to see, copy 1, negative 2, 3, 7 right there. 2, 1, 1, 4, 2, 1, 1, 4, negative 3, 2, negative 2, 10, negative 10, bam, right there. It's easy to get a matrix in here. All you got to do is hit this, get the on-screen keyboard up, click on this weird, next to A, B, C, all the weird hashtag, ampersand, whatever, and you click on this button right here, and you tell it how many rows. Well, there's 3 rows because we have 3 equations, 3 unknowns, but 4 columns because you got the other side of the equals. Hit OK, and then you just fill it in. Once you have it filled in, then you do this. You type in row. Oh, reduced row echelon form. I'm just going to stop typing, click here, and then type my matrix in. After I type this in, it labeled it M1, so I can just type in M1. Hit enter, and there's my row reduced echelon form. X equals -2, y equals -1, z equals 1. Bam. Okay, hopefully that was useful. Long video. Until next time, enjoy doing math.